module, you will learn to compare numbers. 3 numbers are given here: 4,567, 3,560, and 2,789. Which number is the greatest among the 3? To compare them, let's write these numbers in a place value table. All 3 numbers are 4-digit numbers. To compare them, we must first check the digits in the thousands place. The number with the greatest digit will be the greatest. 4,567 has 4 in the thousands place. 4 is the greatest digit in the thousands place. Hence, it is the greatest number. 2,789 has 2, which is the smallest digit in the thousands place. Hence, it is the smallest number. Now, let's check which number is greatest among 7,665 and 7,662. Write the numbers in a place value table. The digits in the thousands, hundreds, and tens place are the same in both the numbers. Hence, we must compare the digits in the ones place. In the first number, the digit 5 is at the ones place, while in the second number, digit 2 is at the ones place. Hence, 7,665 is the greater of the 2 numbers. The numbers given here are arranged from the smallest to the greatest. This arrangement of numbers is called ascending order. Similarly, the arrangement of numbers from the greatest to the smallest is called descending order. In this module, you learnt that numbers arranged from the smallest to the greatest are said to be in ascending order. Numbers arranged from the greatest to the smallest are said to be in descending order. Forming numbers using digits. Digits 1, 2, 5 and 6 are given. We have to form 4-digit numbers using these digits without repeating the digits. Let's use a place value table to form numbers. The first number can be formed by placing 1 in the thousands place, 2 in the hundreds place, 5 in the tens place, and 6 in the ones place. Similarly, we can form more numbers using these digits. These numbers are arranged in ascending order. Here, 6,521 is the greatest number and 1,256 is the smallest number. In all, only 24 numbers can be formed from 4 digits. Now, let's make the greatest 4-digit number using the digits 2, 0, 6, and 4. Since there are 4 digits, we should be able to form 24 4-digit numbers from them. There are some numbers that begin with 0. This means they are actually 3-digit numbers. a number cannot start with 0. Thus, in this case, only 18 four-digit numbers can be formed. The greatest four-digit number formed using these digits is 6,420. Now, we'll use a different rule to form numbers. Using digits 5, 9, 8, and 2, we will form the greatest and the smallest four-digit number such that 2 is in the hundreds place. Placing 2 in the hundreds place, the other digits must be arranged in descending order. The number formed is 9,285. It is the greatest four-digit number formed with 2 in its hundreds place. To form the smallest four-digit number, placing 2 in the hundreds place, the other digits must be arranged in ascending order. The number formed is 5,289, which is the smallest number with 2 at the hundreds place. In this module, you learnt that to form the greatest number from given 4 different digits, we take the greatest digit as thousands digit and arrange other digits in descending order. To form the smallest number from given 4 different digits, we take the smallest digit as thousands digit and arrange other digits in ascending order. A number cannot start with 0. Large numbers. The numbers 0 to 9 are the single-digit numbers that are used to form other numbers. The smallest single-digit number is 0, and the greatest single-digit number is 9. Let's consider the number 9. When we add 1 to 9, we get 10, which is the smallest two-digit number. Similarly, the greatest two-digit number is 99. On adding 1 to 99, we get 100, which is the smallest three-digit number. It continues in the same way, and we have a pattern which looks like this. The number with 5 zeros is 1 lakh, and with 6 zeros is 10 lakhs, and 1 with 7 zeros is called 1 crore. Numbers are read based on the place value of their digits. Let's write this number in the place value table. The place values of the digits serve as indicators while reading a number. To read it, we must start from the leftmost digit. This number is read as 88,76,547. Here, indicators are also useful in writing the expansion of numbers. To make reading and writing large numbers easy, a comma is used. The Indian numeration system has place values ones, tens, hundreds, thousands, 10,000s, lakhs, 10 lakhs, crores, and so on. In this system, the first comma is placed after hundreds place, that is, between the third and the fourth digit from the right. This comma marks thousands. The second comma is placed after 10,000s place, that is, between the fifth and sixth digit from the right. This comma marks a lakh. The third comma is placed after the 10 lakhs place, which is between the seventh and the eighth digit from the right. This comma marks a crore. These commas really make it easy to read long numbers. Other than the Indian numeration system, there is the international system of numeration as well. Let us compare the Indian and the international numeration systems. Till 10,000, both the numerations are the same. But 1 lakh is represented as 100,000 in the international system. Similarly, 10 lakh is a million and 1 crore is 10 million. After 10 million, you have 100 million and then a billion. We can use commas in the international system of numeration as well. In the international numeration system, we insert commas after every 3 digits from the right. Let's take an example as shown here. So, the commas come after the hundreds place, 100,000s place, 100 millions place, and so on. The given number is 56,789,056. In this module, you learnt that numbers are read based on the place value of their digits. The place values of the digits serve as indicators while reading a number. In the Indian numeration system, we put the first comma between hundreds and thousands place, the second comma between 10,000s and lakhs place, the third comma between 10 lakhs and crore, and so on. In the international numeration system, we insert commas after every 3 digits from the right. The ruler. There are 15 units marked in centimeters. Also notice that each centimeter is divided into 10 equal parts, known as millimeters. Thus, 1 centimeter is equal to 10 millimeters. Centimeters and meters are used as units of measurement for small measurements. To measure bigger measurements, higher unit of measure, like meter, is used. 1 meter is equal to 100 centimeters. To measure the distance between 2 cities, higher unit of measurement, known as kilometers, is used. 1 kilometer is equal to 1,000 meters. Thus, to convert kilometers into meters, we multiply it with 1,000. For example, 55 kilometers is equal to 55 into 1,000 meters, which is equal to 55,000 meters. Similarly, kilometers can also be converted into centimeters. 1 meter is equal to 100 centimeters. Therefore, 1,000 meters will be equal to 1,000 multiplied by 100 centimeters, which is equal to 1 lakh centimeters. Thus, 1 kilometer is equal to 1 lakh centimeters. The units of measurement for the weights of solids are grams and kilograms. 1 kilogram is equal to 1,000 grams. Milligram is a unit of measurement used to measure solids with small weights. 1 gram is equal to 1000 milligrams and 1 kilogram is equal to 1000 grams. Liquids are measured in liters and milliliters. 1 liter is equal to 1000 milliliters. Now, let us solve examples in which we have to perform mathematical operations on large numbers. In a city, the number of cars is 2,50,000 and the number of two-wheelers is 11,75,000. How many total vehicles are there in the city? To find the total numbers, we will have to add the two numbers. Observe the addition procedure. Thus, the total number of vehicles in the city is 14,25,000. In the second example, a magazine sells about 4,50,000 copies every month. One copy of the magazine has 60 pages. How many pages will be printed for 4,50,000 copies every month? One magazine has 60 pages. Therefore, 4,50,000 copies will have 4,50,000 multiplied by 60. Observe the multiplication procedure. Thus, the total number of pages printed every month is equal to 2 crores and 70 lakhs. In this module, you learnt that 1 centimeter is equal to 10 millimeters. 1 meter is equal to 100 centimeters. 1 kilometer is equal to 1000 meters. 1 kilogram is equal to 1000 grams. 1 gram is equal to 1000 milligrams. 1 liter is equal to 1000 milliliters.
Jennifer bought 2 kilogram and 300 gram apples, 1 kilogram and 75 gram strawberries, and 500 gram plums. What is the total quantity of fruits carried by her in grams? We know the weights of the fruits bought by Jennifer. First, let's convert the kilograms into grams. 1 kilogram is equal to 1000 grams. To convert kilograms into grams, we multiply kilograms with 1000 in each case and then add the remaining grams. On simplification, we find that the quantity of apples, strawberries, and plums is 2300 grams, 1750 grams, and 500 grams respectively. We add the quantity of apples, strawberries, and plums to find the total quantity of fruits. Therefore, the total quantity of fruits carried by Jennifer is 4550 grams.
By rounding them off to the nearest tens, hundreds, and thousands. In everyday life, you may have heard the words approximately, roughly, around being used in various situations. For example, the population of India is approximately 1 billion. The cost of a standard family car is roughly 4 lakhs. These toys will cost around 100 rupees. These words are used when estimates of quantities are stated. Let's take the example of the cost of two items. The first has a price tag of 96 rupees and the second of 83 rupees. Generally, when stating their prices, we may say that the first item costs around 100 rupees and the second around 80 rupees. In the first case, since 96 is closer to 100 than to 90, we say approximately 100 and not approximately 90. In the second case, since 83 is closer to 80 than 90, we say approximately 80 and not 90. This method of approximation is known as rounding off. So here we can say that 96 is rounded off to the nearest tens, which in this case is 100, while 83 is rounded off to 80, which is the nearest tens to 83. Now we will round off 95. The numbers 91, 92, 93 and 94 are closer to 90 than to 100. So we round off 91, 92, 93 and 94 as 90. The numbers 96, 97, 98 and 99 are closer to 100 than to 90. So we round off 96, 97, 98 and 99 as 100. 95 is equidistant or at the same distance from both 90 and 100. Therefore, as a common practice, 95 is rounded off as 100. While rounding off numbers to tens, we round off the numbers 1, 2, 3 and 4 to 0 as they are closer to 0. Whereas numbers 6, 7, 8, 9 are nearer to 10, so we round off to 10. Number 5 is equidistant from both 0 and 10, so it is a common practice to round it off to 10. Let us see how numbers are rounded to the nearest 100. The price of 2 balls is 125 rupees and 179 rupees respectively. Since 125 is closer to 100 compared to 200, it is rounded off to the nearest 100, that is 100. Whereas 179 is closer to 200 than compared to 100. Hence, it is rounded off to the nearest hundreds, 200. While rounding off numbers to 100, 1 to 49 are closer to 0 than to 100, so are rounded off to 0. Numbers 51 to 99 are closer to 100 than to 0, so are rounded off to 100. 50 is equidistant from both 0 and 100. Hence, it is a common practice to round it off to 100. Next, let's see an example to understand how numbers are rounded off to the nearest 1000. The number of students in a primary section of a school is 850. The secondary section of the school has 1,850 students. Here we see that 850 is closer to 1,000 compared to 0. Hence, it is rounded off to the nearest thousands, which in this case is 1000. Similarly, 1850 is closer to 2000 compared to 1000. Hence, it is rounded off to 2000. Numbers 1 to 499 are closer to 0 compared to 1000. So these numbers are rounded off to 0. The numbers 501 to 999 are closer to 1000 compared to 0. So they are rounded off to 1000. The number 500 is also rounded off to 1000. In this module, you learnt that the method of approximation of numbers is known as rounding off. While rounding off to tens, numbers 1, 2, 3 and 4 are rounded off to 0, whereas 6, 7, 8 and 9 are rounded off to 10. 5 is equidistant from both 0 and 10, so it is a common practice to round it off to 10. While rounding off to 100, numbers 1 to 49 are rounded off to 0, whereas 51 to 99 are rounded off to 100. 50 is equidistant from both 0 and 100. It is a common practice to round it off to 100. While rounding off to 1000, numbers 1 to 499 are rounded off to 0, whereas 501 to 999 are rounded off to 1000. 500 is equidistant from both 0 and 1000. It is a common practice to round it off to 1000.
Estimate the difference between 6,259 and 810 to the nearest tens, and then to the nearest hundreds, to find out which is the more reasonable estimate of the two. The given numbers are 6,259 and 810. We need to round off the numbers to the nearest tens before calculating their difference. Rounding off 6,259 to the nearest tens, we get 6,260, as it is closer to 6,260. Rounding off 810 to the nearest tens, we get 810. Therefore, we need to find the difference between 6,260 and 810, which is 5,450. We need to round off the numbers to the nearest hundreds before calculating their difference. Rounding off 6,259 to the nearest hundreds, we get 6,300, as 6,259 is closer to 6,300. Rounding off 810 to the nearest hundreds, we get 800, as 810 is closer to 800. Therefore, we need to find the difference between 6,300 and 800, which is 5,500. To check our estimations, let us now find the actual difference between 6,259 and 810 to know whether 5,450 or 5,500 is a more reasonable estimate of their difference. The actual difference between 6,259 and 810 is 5,449. 5,450 is closer to 5,449 compared to 5,500. 5,450 is a more reasonable estimate of the difference between 6,259 and 810 than 5,500.
In this module, you will learn how to estimate the outcomes of numbers. The technique of rounding off numbers can also be used to estimate the sum, difference, or product of numbers. To find the estimate of outcome of these operations, the numbers involved must be rounded off to the nearest tens, hundreds, or thousands. Let's understand this with an example. To estimate the sum of the numbers 9,386 and 432, on rounding them off to the nearest tens, 9,386 rounds off to 9,390 and 432 rounds off to 430. Their estimate of the sum is 9,820. We'll round off these numbers to the nearest hundreds. 9,386 is closer to 9,400. Hence, it rounds off to 9,400. And 432 is closer to 400. Hence, it rounds off to 400. On adding the rounded off numbers, we get the sum as 9,800. Similarly, on rounding them off to the nearest thousands, we get 9,000 and 0. The sum of their estimate is 9,000. The actual sum is 9,818. Thus we can see that rounding off to tens gives the closest estimate here. Similarly, the difference between these two numbers can also be estimated. On rounding off to the nearest tens, the estimated difference is 8,960. Rounding off to the nearest hundreds, the estimated difference is 9,000. Similarly, rounding off to the nearest thousands, we get the estimated difference as 9,000. The actual difference is 8,954. We can see that rounding off to the nearest tens gives the closest estimate. Now, let us estimate the product of 386 and 82. After rounding off the numbers 386 and 82 to the nearest tens, we get the estimated product as 31,200. To the nearest hundreds, the estimated product is 40,000. And rounding off to the nearest thousands, the estimated product is 0. We can see that there is a vast variation in the estimates. Rounding off to the nearest thousands is not a good estimation. Here, rounding off to the nearest tens is a good estimate. However, this may be a bit time-consuming. Rounding 386 to the nearest hundreds, that is, to 400, and rounding 82 to the nearest tens, that is 80, gives the estimate of the product as 32,000. This is both a good and quick estimate. There are no rigid rules for estimating the outcomes of operations. The procedure depends on the degree of accuracy required and how quickly the estimate is needed. The most important thing is how sensible the guessed answer would be. In this module, you learnt that there are no fixed rules for estimating the outcomes of operations. Rounding off to the nearest tens, hundreds, or thousands depends on the degree of accuracy required and how quickly the estimate is needed.
Estimate the sum of 3,825 and 25,888 to the nearest hundreds. The given numbers are 3,825 and 25,888. We need to round off the numbers to the nearest hundreds before calculating their sum. Rounding off 3,825 to the nearest hundreds, we get 3,800, as 3,825 is closer to 3,800. Rounding off 25,888 to the nearest hundreds, we get 25,900, as 25,888 is closer to 25,900. We need to find the sum of 3,800 and 25,900, which is 29,700. Estimate the sum of 3,680 and 72,357 to the nearest thousands. The given numbers are 3,680 and 72,357. We need to round off the numbers to the nearest thousands before calculating their sum. Rounding off 3,680 to the nearest thousands, we get 4,000 because 3,680 is closer to 4,000. Rounding off 72,357 to the nearest thousands, we get 72,000 because it is closer to 72,000. So now we need to find the sum of 4,000 and 72,000, which is 76,000 approximately. Estimate the product of 830 and 485 to the nearest hundreds. The given numbers are 830 and 485. We need to round off the numbers to the nearest hundreds before calculating their product. Rounding off 830 to the nearest hundreds, we get 800, as 830 is closer to 800. Rounding off 485 to the nearest hundreds, we get 500, as 485 is closer to 500. By multiplying the rounded off numbers to the nearest hundreds, we get 4 lakhs.
The cost of a single juice can is 10 rupees. A small pack contains 6 such cans in it, while a big pack contains 12 such cans. What will be the total cost of one small and one big pack? The cost of one can is 10 rupees. The small pack contains 6 cans. Its cost will be 6 multiplied by 10, which is equal to 60 rupees. Similarly, the big pack contains 12 cans. Its cost will be 12 multiplied by 10, which is equal to 120 rupees. The total cost of both packs will be 60 plus 120, which is equal to 180 rupees. There is another way of solving this problem. The total number of cans in both packs is equal to 6 plus 12, which is equal to 18. The cost of a can is 10 rupees. Therefore, the total cost of 18 cans will be equal to 18 multiplied by 10, which is equal to 180 rupees. The expressions given here show the sequence in which the calculation is done in both methods. If such expressions are given directly for solving, there are chances of mistakes occurring. To avoid such mistakes, we can use brackets. When solving brackets, a simple but important rule to remember is always simplify the numbers inside the brackets into a single number and then do the operations that are outside the brackets. Now, we will learn the application of brackets to find the product of two numbers. In this example, we'll use brackets to find the product of 106 and 22. 106 can be expanded as 100 plus 6 and 22 as 20 plus 2. Now, place a pair of brackets around 100 plus 6 and another pair around 20 plus 2. Brackets will help us simplify the expression more systematically. Now, we need to multiply 100 plus 6 with 20 and with 2. This makes the multiplication much easier. Simplifying the expression gives 2,332. Let us see another example. Here, we will find the product of 12 and 44 by expanding brackets. 12 can be expanded as 10 plus 2 and 44 as 40 plus 4. A pair of brackets can be placed around 10 plus 2 and 40 plus 4. Next, 10 plus 2 must be multiplied by 40 and 10 plus 2 by 4. 10 times 40 is 400. 2 times 40 is 80. 10 times 4 is 40. And 2 times 4 is 8. 400 plus 80 plus 40 plus 8 is equal to 528. In this module, you learnt that the numbers inside the brackets are simplified into a single number and then do the operations outside.
8 multiplied with the difference of 7 and 3. Divide the difference of 32 and 20 by 3. The difference of 7 and 3 is 7 minus 3. So, the expression for 8 multiplied with the difference of 7 and 3 is 8 times 7 minus 3. The difference of 32 and 20 is 32 minus 20. So, the expression for dividing the difference of 32 and 20 by 3 is 32 minus 20 divided by 3. Mac wants 8 chocolates and Jim wants 20. The cost of each chocolate is 15 rupees. Jim is going to buy the chocolates. How much money will Jim need to buy the chocolates? Jim wants to buy 20 chocolates and Mac wants to buy 8 chocolates. The total number of chocolates is 20 plus 8. And the cost of one chocolate is rupees 15. So, the total cost of the chocolates is equal to 20 plus 8 into 15, which is equal to rupees 420. Multiply 105 with 106 by the method of expanding brackets. We can write 105 as 100 plus 5. And we can write 106 as 100 plus 6. Now let's expand the brackets as shown. Finally, adding all the numbers gives the result as 11,130. Write two different situations for the following expression. 7 plus 9 multiplied with 5. Let's start with the first situation. Sam bought 7 pens for ₹5 each, and Max bought 9 pens at the same cost. Find the total cost of the pens. The second situation can be Rema stitches 7 shirts in an hour and Anita stitches 9 shirts in an hour. How many shirts can Rema and Anita stitch together in 5 hours?
Roman numerals. In our daily life, and while doing math, we commonly use the Hindu-Arabic numeral system. But you must have noticed numbers like you see in this wall clock and the timetable chart. These are called Roman numerals, one of the early systems of writing numerals invented by the Romans. Roman numerals are represented by the letters of the English alphabets. I represents 1. V represents 5. X represents 10. L represents 50. C represents 100. D represents 500. And M represents 1000. Roman numerals do not have a symbol for 0. If a symbol is repeated, its value is added as many times as it occurs. For example, letter I is repeated twice. This means the value of this number is 2. Here, it is repeated thrice. Hence its value is 3. The symbols V, L, and D are never repeated. Now, look at this number. Here I is written to the left of V. When a smaller value symbol is written to the left of a larger value, it is subtracted from the value of the larger value symbol. Here the letter I, which is equal to 1, is written on the left of V, which has a value of 5. This means 1 is subtracted from 5. Thus, the value of this Roman numeral is 4. Now look at this number. Here the letter I is written on the right of V. When a smaller value symbol is written to the right of the larger value symbol, it is added to the value of the larger value symbol. Thus, the value of this Roman numeral is 5 plus 1, which is equal to 6. It is the same in the case with numeral IX, 9, and the numeral XI, 11. Roman numerals are read from left to right. Let's read this numeral. Since we read from left to right, the letter I is before the letter X. We subtract the letter I from the second letter X, which is 9. Now, we have only letter X on the left, so we add the 2 to get 19. The symbols V, L, and D are never written to the left of a symbol of greater value. So V, L, and D are never subtracted. For example, we write 15 as XV and not Vx. Moreover, the symbol I can be subtracted from V and X only. For example, letter V minus letter I is 4. Similarly, subtracting letter I from letter X gives 9. Subtracting letter I from XV gives 14. And subtracting I from XX gives 19. Symbol X, or 10, can be subtracted from L, M, and C only. For example, letter X is subtracted from the letter L to arrive at 40, which is represented by XL. Similarly, the letter X is subtracted from the letter C, which stands for 100, to arrive at XC, which is 90. Let's write 800 in Roman numerals. To make things easy, let's break up 800 as 500 plus 300. 300 can be further broken up as 100 plus 100 plus 100. The symbol for 500 is D. The symbol for 100 is C. Replacing 500 with D and 100 with C, you get 800 as DCCC, which is the sum of D, C, C, and C. Let's see how you write 95. The symbol used for 100 is C. Remember that symbol X can be subtracted from symbol C to arrive at 95. Subtract 10 from 100 and add 5 to it. Here, X should appear to the left of C because it is subtracted from C. In this module, you learnt that the letters I, V, X, L, C, D, and M are used to represent Roman numerals. I stands for 1, V stands for 5, X for 10, L for 50, C for 100, D for 500, and M stands for 1000. Roman numerals do not have a symbol for 0. When a smaller value symbol is written to the left of a larger value, it is subtracted from the value of the larger value symbol. The symbols V, L, and D are never written to the left of a symbol of greater value. So V, L, and D are never subtracted.
Write 59 and 235 as Roman numerals. 59 is equal to the sum of 50 and 9. The Roman numeral for 50 is L. The Roman numeral for 9 is IX. Replacing 50 with L and 9 with IX and adding L to IX, we get the Roman numeral for 59 as LIX. Now let's solve the other part of the problem. Write 235 as a Roman numeral. 235 is equal to the sum of 200 and 30 and 5. The Roman numeral for 100 is C. Therefore, 200 would be CC. The Roman numeral for 30 is XXX. the Roman numeral for 5 is V. Replacing 200 with CC, 30 with XXX, and 5 with V, we get the Roman numeral for 235 as CC XXX V. Write XLI and DLXIX as Hindu Arabic numerals. L is equal to 50. X is equal to 10. I is equal to 1. XL is equal to 50 minus 10, which is 40. Adding I to XL, we get XLI. Replacing XL with 40 and I with 1, we get XLI, which is equal to 41. Write DLXIX as a Hindu Arabic numeral. D is equal to 500. L is equal to 50. X is equal to 10. IX is equal to 9. DL is equal to the sum of 500 and 50. DLXIX is equal to the sum of 550, 10 and 9. Therefore, the Roman numeral DLXIX is equal to 569. Write 247 as a Roman numeral. 247 is the sum of 200, 40 and 7. 200 is equal to 100 added to 100. The Roman numeral for 100 is C. Therefore, 200 is equal to CC. 40 is equal to 50 minus 10. The Roman numeral for 50 is L. As X is subtracted from L, it is written to the left of L. So, the Roman numeral for 40 is XL. 7 is equal to the sum of 5 and 2. The Roman numeral for 5 is V, and for 2 is II. Adding V to II, we get VII. The sum of CC, XL, and VII is CC, XL, VII, which is the Roman numeral for 247.